everyone. Let's see. Let's wait for a couple of people to get on and let's see what we can do today. Let me open a few things. Yeah. So, how's it going today? Just put a message in here and say, and we are live. So, I think I can do a little recap of what I've been working on for the last couple of weeks, and sort of where we'd be going for a bit, and then we'll see about that, and then we'll kind of jump into today's session. I kind of realize it might be even a shorter session today, but we'll see about that, and yeah, we'll see. Cool. So here's the thing. Over the past couple of weeks, I've been doing daily streams, and on my daily streams, I've been working on basically, you can call it a sample Zephyr application that's trying to be as real world as possible, where we basically build an app, and we try and tackle real world issues in a way that can be applied in in production in the real world, and that's pretty cool. I think that's a really nice way of learning. It's a really nice way of discovering things, and I think it's going well. So yeah, so far we've covered mostly the Zephyr application, and then I think a couple of weekends past I did do a a couple of neurons applications where we built a sigmoid and a perceptron neuron, and I probably will go back to that a bit later. It's just I've been busy at work with some preoccupying stuff, so I haven't had much time to read on the first principles of building neural networks. So yeah, we'll get back to that. Anyways, that's a little recap of what we've been doing, and going forwards we'll be doing that. Most of our explorations will be in, can I call it, low level stuff. We'll be working with microcontrollers. We'll try and go into some assembly. We'll try and work with some cameras. We'll try and work with some FPGAs. I have some vision FPGAs that we can work with, and yeah, just that the one I have now is a really complex one, and I'm waiting for a simpler one to kind of arrive so that I can do that. But long story to today's session. So if you were with me yesterday, or if you watched the previous stream, you'd realize that we actually did manage to fix our we did manage to fix our finite state machine, and we got it working. But then after our finite state machine was working, we realized that going from connected to disconnected in Bluetooth was having an issue, and basically what ended up happening was we decided there's a logo on my face. I'm trying to remove it. There's a logo on my face, and I would like to remove it. Where is it? Just a moment. So yesterday we built when we integrated the finite state machine into our BLE application. Whenever you went from connected to disconnected, you couldn't reconnect back. And I think we tried for a bit and somehow ended up stopping because I didn't want to spend too much time, and I had a family branch to go to. But then I left out a challenge, and I think it's Bartholomew worked on a fix for us, and it actually fixes it. My approach was going to be different because I went through Zephyr peripheral. So we'll jump around and then we'll come back to this one. So initially I thought that the issue would be that we were calling, I'll just look at this PR and then we can kind of surmise from there. We were calling LE start advertise in the wrong state, basically. We were in, I thought we were having like a timing issue where we were trying to use we were trying to use we were trying to come on we were trying to use APIs that were conflicting, and I think we can actually almost discover that before we go apply the fix, which Bartholomew has done for us really. Let's look at where we are. Let's get, come on, git branch. I believe we're on the other one. Okay, cool. Git check out PR add state machine. Okay, clear. And so the first thing I want to look at is our project.config, our kconfig stuff, and this config bt log level warning. Yes, let's actually put it at debug dbg. I want to put it at debug, and then I want to run some logs so that we can see what is actually happening before we apply the fix. And I have a feeling that we're calling advertisement start when there's already an advertisement before stopping, or we're calling advertisement is it BLE service? So I have a feeling that we have some sort of race condition happening here. Race condition happening, disconnected here, somewhere here. Okay, I have a feeling that that is actually indeed the problem. So let's just west control R activate. Yeah, control R west build. Okay, let's build it and see. I just want to look at the logs, and then just so that we can know what was going wrong, because we already have a fix. Basically, the code has already been done. It is on this PR, and once we put it in, it fixes everything. But I want to see if we can generate some logs and see what we're actually fixing. And we will look at these APIs, because Bartholomew applied the recycled API. So I think it would also be prudent to go through the Bluetooth callbacks and just look at them, try and remember them for next time. Yep. Cool. We're building. Letter C. Almost. Onwards up. If you guys are interested in knowing, there's usually a kitten sitting on me. This is Yan. This is Yan. And she's very giant. She's a 4-month-old. Are you 4 months or 5 months? She's a 4-month-old and giant for her age. Yeah. And she's usually on my lap. And she's got a sister called Yin. Somewhere around here. But we'll see. Okay, cool. So that's built. I think HW packet into a pack. And then I'm gonna do something like that, and then I'm gonna do EFU, and then I'm gonna load it, and then let's see. While that's loading, Control R, and then we'll say screen, and then we'll wait for it to completely load, and then we'll run that command. Cool, amazing. So let's run that. And yeah, so amazing. We have a lot more logs, but let's see if we can get an error out before we go and apply the fix. So if we connect, I believe if we connect, we should see some sort of connection. Cool. Let's run a connect. Yeah, see, we got a connect. Bum. Connection. No connection wants to do stuff. That's okay. That's fine. It's odd. It's not presenting me with any services. Oh, that's odd. I wonder if it's because... That's really odd. That's really odd. So let's try again, please. Let's try and see if we can get some errors. It'd be nice to get some errors so we can see. 1, 2, 3, 4. Connect. Oh. Yeah, it's fine. Okay, cool. Yeah. So let's try. I'm gonna try and connect again. Okay. The connection has timed out unexpectedly. That's insane. That's insane. But here, oh, I see what was happening. So yesterday I tried to apply some patches. You might notice this is a new. This is actually not a log. This can be just a one. Actually, I ought to start going back to info. Yeah, I can do inf, and then I think I'll remove this. This was me trying to fix it last night, and then we'll get back to this, and then I think remove that as well. And then there's some part here where I need to remove it, and then that. That's a default. Default? Yeah. No, this was just me trying to fix it yesterday. So let's do another build, hopefully. And then, no, that we need to do our actual build. It's odd because that sort of worked yesterday, but it didn't actually work. So I never actually got to committing it, and I abandoned it and left for branch. Cool. I just want to see a log that tells me what is breaking. Let's actually look at my PR here and look at the version of. It's amazing. Try to add. We just try to add. Tried to add a state machine, and we ended up fixing networking errors. That's insane. So I think they yeah, this is a service. Let's see, there should be a connected and a no. I need to look at the files in the custom. Yeah. Wow. Remember to say hi when you join. Remember to say hi when you join. Let's see. Is it actually built? So I'll look at the files changed. And I intend on looking at Bluetooth release. And let's see, and disconnected the ones that we had today. Connected and disconnected. Connected, yeah. You just did that, and then disconnected. There's that. That's fine. That's okay. I didn't want that. Okay, cool. So I just removed those. I'm gonna pack it. I have kitten fire in my mouth. Now I'm gonna flash it. It's fine. And I think we want to start actually. That's the next PR. That's the next PR. Let's actually add an issue somewhere here. so that we know, so that if people want to work on stuff, they want to work on stuff. Please go all the way up. Yep. Yeah, it's been programmed. We'll do that. We'll do a test now. Let's add an issue. So new issue. Stop using log one, and move to a more sane logging level upward. Okay. Yeah. We use log one in lots of places because we were avoiding log inf from BT. We should move to another level. Just a moment, guys. Just a moment. Okay, cool. So let's see what we can do here. Yeah, let's file that issue. Create. Okay, cool. Just a moment. Just give me a moment. There's noise in my house. Sorry about that. There was a bit of background. But yeah, we're back. So I've added an issue for that to now stop using log one everywhere. So that's cool. Let's run the app. Let's run the app and get some logs. Let's get some logs here. That's really slow. Why is it doing that? Connect. I started to shit. 1, 2, 3. Yeah, cool. So let's now connect. Nice. No connection wanted to do stuff, but it's still timing out. Connect. This is so odd. The branch fails. My branch fails. I don't understand. And Bartholomew's branch, this one doesn't fail, but this is based on the one that is over there. Doesn't change much really. Advertising stat. But if I connected, yes, there is a default con here. There is a con being unrefed here. Anyways, we can't get the log for why it's wrong. So not today. It doesn't want to give us the log. It just crashes. No connection wants to do stuff. So that's really odd. That's very, 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 very odd, because that's very odd. Okay, cool. Let us see if this fixes it then, as I tried earlier today. Yeah. CD. We'll do that so that thing stays. Not CD. Get checkout. Fix connection after disconnection. Git clean. Check out. Just dump those changes. Clear. Git check out. Let's just go back up twice. Yeah, let's do that. This actually works super good, and we will know now. We will know why just now. For some reason, my allergies are getting so much better today. Cool. Does anyone have any questions so far, even though most of that was just being wondering why it wasn't working? No questions? Let's build this. Let us build this. I do have audio, yes. While that's building, this is the FPGA I have. I have this guy. It's Tiny Clunks NX Tiny Clunks 33. I'll type it in, and this is meant to be a Vision FPGA. It's a Vision board, and it's got two IMX cameras that go into either. It can take four or five cameras, but basically you can see two ports here, and those two ports each take a MIPI cameras. So I have two IMX 219s that are connected to this, and this is running Lattice and Crosslink NX FPGA, which later we're gonna learn how to put Zephyr on that and build camera applications on that, and also some RTL if we are lucky. Okay, cool. So let's pack this. Okay, cool. That's packed. Let's flash this. Wow. That's so amazing. It's flashing, and then we should be able to check this. But I did check it earlier today and it worked. But sometimes things never work on stream, and I don't know why. So cool. So that's flashed. Let's run it here. Amazing. You see it's running. And if I do connect, you'll see it will start sensing. That's cool. It's sensing now. That's happening. And if I disconnect, it should stop. Cool. We shouldn't use an error up there, probably. Yeah. And then here's a magic part. If I connect again, it goes back. Amazing. Thank you, Bartholomew. This is amazing. This is cool. Like this means FSM has been hooked up into the application properly, and it actually is sensing what we're doing, and we're moving from state to state, and the application is not dying. So let's actually go back and do some silly stuff. Let's merge this in. Yeah. Get check out PR add state machine. Cool. git merge fix dash dash f dash only git push. There you go, it's up there. Perfect. So this is it. Let's do a really short recap of why that worked, and let's explore like the documents of why that worked, and then we can do a short stream today, and I can go figure out this FPGAs now. So the change that happened, oh my word. So yeah, let's look at the change that was added. It might even have disappeared from GitHub because it's deleted. Custom. Let's see. It's already gone. But I can pull it up. 3 closed. There's that one. So what was added here? What was added here, if you notice, is there was a on-recycled callback here. And this on-recycled callback managed to, whenever the connection was recycled or the connection reference was recycled, it would restart advertising. And then I see there was a change to start advertising. This removed it, but we now call the start advertising one function here, which is fine. My strategy was going to be to add a work queue, and then use post events into the work queue, and then based on those events either turn off the connection or not. And I got that from going through most of the peripheral samples on Zephyr yesterday, and I went through until I found one that connected and disconnected, and then I looked at I basically walked through the code, and I realized they were using a work queue to post up and pull down events. That's also how I fixed the state machine issue. I went through the 2 examples that are on the Zephyr repo, and I would try each one of them, and I would see which one would work, and the one that I saw was working was using message queues for that. So I think since we just got some code and it worked, let's perhaps just jump into the documentation for Bluetooth callbacks, look at them, and then probably we can do quite a short session today. I like it. Then I do want to go back to audio, but I don't want to start it in the middle of... We can explore what is going to happen. Yeah, cool. So let's look at this. So first of all, BTCon callback struct reference. So there's a struct that is provided to us that that we can register callbacks for, Bluetooth callbacks using. So the callbacks that we can register is a few. Let's actually walk through them all, because this is going to be key later. This structure is used for tracking the state of a connection, and it is registered with the help of BTCon callback register API. And it's permissible to register multiple instances of this BTCon CB type. What does that mean? We can add many different, we can register the callback many times in case different modules of applications are different and interested in tracking the connection. Oh, I see. Oh, wow. Now, this is why we read the documentation, because we wouldn't have known this. So basically what they're saying there is what they're saying there is, if we wanted, let's just say for, this is actually cool, which means we can move most of our work into the FSM, but we won't for now. What that means is we can register that connected and disconnected callback several places in the applications. Some places might just want to know that the connection became alive and the connection did not become alive or died. And imagine if you're doing something where you probably need to preempt stuff, you know. You want to be fast, You want to be fast. Maybe there's some data that you need to fetch from, say, SDIO, SD storage. And you know that if someone connects to this endpoint, they're going to probably want data from that endpoint. So you can't use those callbacks in other modules, and in those other modules you can choose to react to connections and disconnections. Maybe you're streaming audio using something like BTL audio, and then what you want, but you have a module that is doing is passing or is doing some synthing or is mixing your audio, and it's going to forward it. But that module does, the mixing module does not need to always be mixing in case a connection disappears. So it can stop. It can stop, and then you can save work. You can make the headphones last longer if you don't do work when it's not needed. So being able to connect, to track the connection state all across your application now becomes a really cool thing that we can do, and it actually offers a lot of implications on power saving and speed and other things. So it's cool. So let's go through this. That's why we read things like this. If a callback is not of interest, for instance, it may be set to null as it will as a consequence not be used for that instance. Okay, cool. This is it. So you can register different callbacks with different instances. So different modules can all register callbacks for a connection, but then and then they can all react to different callback events, basically. And you can choose to ignore the ones you don't want. You don't have to use a uniform one everywhere else. Okay, cool. That's cool. That's amazing. So, a new connected. Let's look at all these callbacks. It's a list of a bit, but let's look at them. So, connected. A new connection has been established. This callback notifies the application of a new connection. In case the error parameter is non-zero, it means that connection establishment failed. So there is that. I also remembered another issue. I hate this. I hate somehow I'm always just confused when I do like a lot of things. Convert possible Bluetooth errors and states to strings for logging. Yep, just make a new issue. Yeah, so basically you can, instead of posting a hex, there's a helper function that we can call, and it can make strings for us, and we can know. Okay, cool. So the error can mean one of the following in connected. BTHCI error unknown connection ID. Creating the connection started by that was cancelled by either the user through the BT con disconnect or timeout in the host through the con parameter timeout. Okay, cool. So the connection can either timeout or high duty cycle directed connectable advertiser started by. Yeah, so connected can fail using timeouts. Basically, yeah, if the timeout is crossed for when you need to respond to connections either from the peripheral or the central, a connection can fail. Let's look at the next one. Disconnected. A connection has been disconnected. Okay. This callback notifies the application that a connection has been disconnected. When this callback is called, the stack still has. If we read this yesterday, we would have managed to fix this. When this callback is called, the stack still has one reference to the connection object. If the application in this callback tries to start either a connectable advertiser or create a new connection, this might fail because there are no free connection objects available. To avoid this issue, it is recommended to either start the connectables advertise or create a new connection using k work submit or increase config max. If we read this yesterday, we would have fixed it. Because I wouldn't have had to go through all the applications to discover that I need to, anyways, or increase this. This would have also fixed it yesterday. Okay, cool. Let's check the next one. Identity resolved. Remote identity address has been resolved. I guess this is something like login success. Yeah. So in case you're doing secure Bluetooth, where you're depending on like you need to know who is on the other side before you can send some data or before you can fetch some data. Imagine you're doing something like you're using MCU boot and you're using its SMP server, simple the SMP server for MCU boot, and you want to know that you're getting an actual correct what is it called? Correct binary for doing the firmware over the air updates. In case you're doing something like that, this callback will become quite important because you would need to know that the other side has been authenticated and you know them before you apply this, before you either accept it or apply this update that they're sending you. So cool. And then this can fail. Can this fail? Yeah, no, this can't fail. And then LE data length updated. So this is the when we get to a point where we're sending custom data by ourselves, and this right now we are sending custom data, but it's not of a variable amount. It's just one. So this, I guess, will come when we need to send different bits, different data of different sizes. And excuse me. And it will basically help the application be aware that, you need to do a buffer size, this size, buffer size, that size, or whatever. And then let's see. There's a LE param request, LE connection parameter update request. Okay. This callback notifies the application that a remote device is requesting to update the connection parameters. The application accepts the parameters by returning true or rejects them by returning false. Before accepting, the application may adjust the parameters to better suit its need. I kind of feel like we want to go look at those. Look at these. What are connection parameters? Just so we know. So interval. We're back to power saving. Amazing. You like that? So interval min, interval max is how many times you're sending out your advertiser. How many times your radio is pinging? I'm here. And if you want, I guess, let's think about it as a power saving thing. In this respect, you can, once you connect, you can tell it, okay, don't send so often advertisements right now because you're already connected. Or once you connect and you want five other people to connect, you can adjust it so that it sends them faster. Remember, in one of the previous streams, we talked about, I think it was the power one, we talked about the interval min and the interval max and how we can adjust them to save power or to make it or make the application more available for people, and you can. So the thing that is happening here is that the central application can request the peripheral application to change the interval min and max, which means in essence the central application can also influence the power characteristics of the peripheral application, if that makes any sense. Okay, So there's that. The LE connection parameter update request. Yeah, cool. So the central can send a request to update the connection parameters, and then if the peripheral is comfortable with the updates, then the peripheral will do the updates and probably send a thing back. Or it's actually, it might send them back. It might react to that, but in the callback, we have a chance to react to those update requests, basically. Cool. And then, just a moment. Cool. Yeah, so this is the one. LE param updated. So if the peripheral does choose to indeed update the connection parameters, it can then notify you or notify the application via the callback that the connection parameters have been changed. And this is also another thing. Remember, then you can start doing like, oh, if the central changes my connection parameters to this state, I can go to that FSM state, and then I can go to this, and I can go to that, and such, and so on and so forth, basically. And then let's keep going. And then the phi of the connection has changed. This is where you can change. Let's say you have an application with two or one or more than a singular radio, okay, and you want to choose which radio you like, have like a high power radio and a low power radio, or a long range radio and a short range radio, whatever, whatever combination you want, and you want to be able to choose them. And this is a callback to tell you that a change has been made between one of them. And then we finally get to the one that Bartolomeo actually applied for us. A connection object has been returned to the pool. This callback notifies the application that it might be able to allocate a connection object. No guarantee, fast come, fast serve. Use this to restart connectable advertising or scanning. Treat this callback as an ISR, as it originates from BT Connect and Ref, and which is used by the BT stack. Making Bluetooth API calls in this context is error prone and strongly discouraged. So again, if yesterday we had read through this, we would have fixed this by either doing this. We would have probably tried the KWAQ above before, because we wouldn't have gotten to this. But now this is how we learn, basically. The role of the connection has changed. Role changed. So I guess this is when you can go from peripheral to central and such, and based on that you can do different things. Like you can become a server or a client, and then based on being a server or a client, you can change your API, you can change this, you can make things possible and not things impossible and such. So that's cool. And then the last one will be security change. The security level of a connection has changed, and this I think is bonded and non-bonded or something. This is the bonding parameters. So the security level of a connection has changed. This callback notifies the application that the security of a connection has changed. The security level of the connections can either be increased or have been increased or remain unchanged. An increased security level means that the pairing procedure has been performed or the bond information from the previous connection has been applied. If the security level remains the same, this means the encryption key has been refreshed for the connection. So these are all, that one was about bonding and pairing. But these are all of these are callbacks that you would use in your application, and you would need to sort of design your application knowing that this might occur, so that you can change the way you react to stuff. You can present as a general Bluetooth device, and then once someone has bonded, you can suddenly be like, oh, I know you. You can now start presenting, oh, I have this service, I have this characteristic, I have this service. You can become headphones, you can become this, so that way you're making sure that that you're working through security. It's basically authentication. It's an authentication flow. You connect first, cool, and then you authenticate. You know who is on the other side, and then because of the authenticated and you have the information, you can authorize them to do things, this or that. That's almost as simple as it is. Okay, cool. So we have gone through all of this, and we know about all the connections, and surprisingly enough, it's almost taken an hour. Let's go merge the state machine thing and then open an issue for the next thing we need to do, and then we can close the stream from there. So yeah, git check out main, git rebase -i main. Cool. Git check out main. Git merge br state machine. That's just ff just only. Amazing. Git push. That is up. I hope there's no malicious code in. Yeah, that's fine. That is fine. That's okay. That's fine. Ooh, look who's the latest committer. It's not even me. I'm so happy about that. I'm not working on this by myself in the dark. Okay, cool. So let's open an issue. Add hysteresis. Is that what you call it? Hysteresis. Hysteresis. System hysteresis. Yes. Yeah. Okay. Add hysteresis to the sound sensor. We have an audio thread that is triggered every few seconds. We would like this thread to notify Bluetooth Central that it detected some sound above a certain threshold during its running. So steps. Add a stable hysteresis measurement, so we don't have flippant voice audio level changes. Add a BT service, custom BC service, a custom BLE service that notifies the central when there is audio above a certain threshold. Okay, so yeah, let's do this. Let's do this. Let us do this. Great. So let's actually explore what needs to happen here, and then we can close up for today. And number one, thank you so much, Bartholomew, for the fixes. That was amazing. It's really cool. It feels so nice to be working with someone. This is the whole point of doing streams and such, so that you can work with someone. Let's see. So we have this audio service here. We have this audio service here that we'll explore later, but let's look at what the audio service does. So whenever this audio service runs, it senses audio. Whenever it runs, it senses audio. And what it does is it gets the RMS of the audio signal that is coming through. And the RMS is a root mean square. Root mean square is how you calculate like the AC level. AC level of a signal. Well, combined AC and DC level of a signal. So basically, what it does is, or what RMS does is, it accounts for background audio, and some audio happening in the there's background, like, I don't know if you guys can hear, but there's birds around me. There's birds. I live in an area with a lot of birds, and that's probably why my cats are so big. But I live in an area with a lot of birds, so there's always a background hum of birds singing, and then maybe my watch has a tick or something like that. But what I'm trying to say, there is background audio and then there's active audio in the front of it. And whenever you are sensing continuous signals in the real world, what you want to do is you want to separate. You want to separate or you want to account for the backgrounds. And right now, if you go to the previous, one of the previous streams or such, you'll realize that our system is set up so that it can record 300. I think it is 0 to 3 is 400 milliseconds of audio. But remember, all of those, it records those 400 milliseconds of audio in 100 millisecond batches. So there's three batches. You can see them here. There's three batches. So here it is. It records 400 milliseconds of sound, but each sound is a block, and each block has 100 milliseconds of audio in it. Okay, so it records 400 milliseconds, but in batches of 100 milliseconds each. Cool. And what we want the sensor to tell us, the audio sensor to tell us, is, I detected audio above this. This level when I did my detect run, and I detected audio when I did my detect run. I did not detect audio above this level. However, we wanted to account, like I said, we want to account for background noise, and for we also want to account for noise. We don't want it to, if it's a digital signal, it would go on off, because it's sensitive to a certain threshold. And then that's where hysteresis comes from. And hysteresis here is, it kind of finds what you do is you use two thresholds. You use an upper threshold and you use a lower threshold. If when the system is starting its off, you wait for it to cross the lower threshold and then it's on. But because audio signals are real and they change, it might, like when you're talking, there's space in between words. So what you want is, you don't want it to say noise, no noise, noise, no noise, noise, no noise. You don't want it to say that. You want it to tell you, like, I generally detected audio, or I generally did not detect audio. So you have two thresholds. Basically, you have an upper threshold and you have a lower threshold. If you cross into the upper threshold, so now there's noise, you have to wait until the signal again crosses the lower threshold to say there's no noise. Not to just, so let's assume, can I make another this? Can I draw something? Draw the dial. So think about it like this. Come on. Just one simple explanation and then we're done with today. That's cool. While this is loading, if anyone has a question or can explain this better, put it in the comment. Obviously, talking to you, Bartholomew. Yeah, this is a state machine that let's delete that. So we want to draw and we want a line. We want this here. Can I do freeform? Can I do freeform or something? Anyways, let's do it here. So you have a threshold here. This is an upper threshold. And then you C, Ctrl V. And then you want a lower threshold. Okay. This is, let's say this is off. And then this is on. Okay. And then this is yeah, let's take another one. Let's put this here, let's put this here, and then let's call this an axis. Okay, call it an axis. This is it's fine. And then we want to point this guy here, and then we call this one an axis. So this is as time goes by, and then this is the audio. I should get some sort of pencil situation. But here's the thing. What we want is when audio actually crosses the on threshold, okay? Pencil. Basic. I just want to draw something freehand or something. It's no here it is. Yeah. Can I get something where I can just draw? Anyways, I don't know. It's easier for me. This is why mathematical symbols, mathematical formulas are easier. But basic, can I just get something I can draw? No. I just want a line, man. I just want to be able to draw a line. Some line. Yeah, let's say your signal starts like sketch online. Give me a moment. Give me a moment. I will make this work. Yeah, so let's look at this. Amazing. Yeah, give me that. I won't save anything. Just give me this. And then let's Control C. It's fine. That. There's the two axes. So okay. So we have a lower level and a higher level. That's fine. And then the noise. So this is, let's say, 0, 1. These are all levels. So whenever we start sensing, we set everything to there's no audio, and for it to become for it to register. Thank you Nathan. I'll check out Excalibur. For it to become on, you want to go up. We want the level to go cross the top threshold. So this is the on threshold. This is the on one. Yeah, this is the on threshold, and this is the off one. Okay, this is the off threshold. So here's the thing. The thing we want to do, the reason we want to implement hysteresis is so that whenever we go on, we wait until it goes off for it to say off, okay? Rather than, if we have just, imagine a system with just one threshold, you see? And then you just every time you go up, every time you go up, every time you go up, and you just have this. You see? Can I zoom out? Zoom out. Okay, cool. But it doesn't matter. What I'm saying, if you have this, your audio will be very flippant, very flippant. Like your sensing will be like on off, 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 and that is actually what we have right now. That is what we have. Let's run this version of the app so that we can see. So let's run the audio service and see what happens. Here instead of doing that, so let's log error so that we can see it. Log error. Log error. Audio level sensed. And then there's that, and then we want to do. Isn't it an F? I think so. And then we want to do something like that. Yeah, I think something like that. Why? Okay. Okay, cool. So let's build that and we see. Okay. So let's first build the problem, and then we will set a date where we come back and we apply the fixes for that problem. Or if you can do it like Bartholomew, and then I just end up doing a review stream, that would be awesome. Jump in, do it, put the code up, don't be scared, break stuff, don't worry about it. Remember, this is just, if you play harder than you work will never be hard. So just try it here, and then after however many years, whenever you're out of Bluetooth, you already know how to do it because you've done it before. That's how it works. It needs to build. I need to go on an ARM so that this can build. Speaking of, either ARM or something with NVIDIA, because I need to run my lattice, the design software. So when you're writing code, when you're writing Verilog, let's, where is it? Get that. So when you're writing Verilog, it's not, you write code. It looks like C, but it's not called coding. It's called, you don't have to do it. Someone else. But you might even be able to pull it off without the thing. You can just code it and we can test it here. Some of these things are private, but anyways, it doesn't matter. So when you write Verilog, you build a system and you design a system. It's code. It looks like code. But it's not called coding, it's called designing, because the end product of this is actually hardware SoC, or system on chip. So you call it design, but you write the code. So that's a thing that is actually going through my head that is messing me up. Let's pack it. That's cool. Let us flash it. Let's put this. Let's flash it so we see that. Okay, cool. And this will be awesome because for the first time we'll be able to just activate the. Oh, this is cool because the application is becoming its own thing. So cool. So you see, it's in idle. It's not doing anything. Number one, we've won because the state machine is actually doing the thing we wanted it to do. And then now if I connect, yeah. Anyways, so this is the thing I'm trying to show, that there's all these audios are floats. All of those floats are audio, and some of them are low and some of them are high, and it's because there's background audio and it's because there's foreground audio and there's all of these things that are happening. And what we want to do is decide a threshold that shows that there's audio being sensed and there's not audio being sensed. And then we want to develop it's literally like 4 lines of code. It's more learning than it is actually writing of the code. You want to check that the upper threshold has been crossed to say that you're detecting, and then check that once the upper threshold has been crossed, you don't check again the upper threshold, you check that the lower threshold has been called to detect it going off. Yeah, and that's what we're going to be doing next time in next stream. And that whole filter thing is called an hysteresis filter. Basically, it's a system. The English is even simpler. Hysteresis is the dependence of the state of a system on its history. Okay, so if it's on and it's staying on, you leave it on. If it's off and it's staying off, you leave it off. Or if it's on and crossing to off and stuff of the sort. So you have to basically account for where it's coming from. You're not just accounting for what is happening now. You're accounting for where it's coming from. And as an interesting side part, we're recording 300 ms of audio because we want to eventually make this thing become a keyword detector, a keyword spotter. So at some point we will be able to talk to our little board, this guy, and go like, I don't know what the keyword we will use is, but hey Nordic or something like that. We'll tell it something, or it's like or if we're crazy we can just call it Jarvis and be like Jarvis, and then it will do stuff, and basically we will build up to that. But there's all of these concepts to doing that. Eventually we might even end up using something like TinyML and running it on TinyML and stuff of sort. But it's very beneficial to read through and build up and do everything along the way like you're going to do it, so you understand what is happening in the background, so that in the end, when you have to debug this thing, because you will have to debug this thing, you actually know. You don't have to do the things, but you need to know where everything is happening, so that when something doesn't react right, you have the intuition to go and check in the right place and such. So thank you all for coming today. Thank you, Nathan. Thank you for the comment. Thank you, Bartholomew. Thank you for the code. I'm so happy that there's someone else who's working on this code. Ask as many questions, open as many issues as you guys want. Let's adapt this code to run on different hardware. It's very easy with Zephyr and stuff of the sort. Yeah, thank you so much. It's lovely to see the community growing. Tomorrow we handle an hysteretic. Yeah, this is hysteretic. Where is it? Here you go. We handle a very simple DSP filter called an hysteretic filter. So it tells us whether the audio is going up or not and such. We might have to debug audio because those levels are very similar. So we might either have to debug it or go backwards a bit, but we'll see. Thank you so much for coming. This has been awesome. See you guys tomorrow. Cheers. That was lovely.